And for that, then I would like to introduce a man that I like to describe as a Swiss knife, but he is really an expert in everything that has to do with carbon and oils. So he's a consultant. He created already Wolferdor's Consulting in 2015, and since then has been advising spreading the word about recycling in the broader context, not only for mechanical recycling, but also for chemical recycling. And he has the chance to moderate the next panel, which is the million-dollar question, if we are ready for chemical recycling. We are very much looking forward to it. So Martin, please, the stage is yours, and I would like you to give the floor to the speakers as well.
Thank you, Alejandro. Thank you. Are we warmed up for the hot topic, which is chemical recycling? Who is warmed up? Woo! Yes, very good. Okay. So to start, I want to start with a little story. We had the Azure network meeting last week. And guess what? We discussed chemical recycling. We were guests at Mesa Gases. And you have to know, in Azure, I'm also leading a group that is working on advancing chemical recycling. And so we had a little workshop, and we had to answer the question, what is needed for a 100% circular economy? And this is a really not trivial question. This is very, very complex. Can we just organically grow the circularity and then we are 100% circular, or do we have to scratch everything and start from new? And I want to share, actually, in my group, with the work group Chemical Recycling in Azure, what we found is we need two things. We need to have the policymakers on board, and we need to have the consumers on board. It has been said today, consumers are buying tires, they need to be round, black, and cheap. And we need to advance on that. We need to advance what tires make, we need to advance on the sustainability of tires, and we need to advance on the knowledge of the policymakers. We talked about the absence of policymakers here. However, there is a group of people, organization that can help us. And so I would like to welcome the first panelist, actually working for an NGO. I would like to welcome Lauriane Veillard. I hope I pronounced your name correctly. Lauriane is Chemical Recycling and Plastic to Fuels Policy Officer at ZeroWasteEurope. She has studied political science in Rennes, in France, and she's 2 years at ZeroWasteEurope now, and she has also spent an internship at the European Parliament. Welcome, Lauriane. Then I think we couldn't have a better lead over and introduction to ecosystems for the chemical recycling. We need ecosystems, and the really first ecosystem ever that was presented, we just had the presentation from Margarita Dorato. So welcome, Margarita, again. Good to have you here. What I find also interesting, you not only worked on circular materials, but also on the bio butterfly. So renewable and circular, which is adding up to the sustainability of tires. We have another colleague who is also part of the Blackcycle system, and I would like to welcome Celso Magri. And Celso is Global Marketing and Sustainability Director at Orion SA. We know Orion as Orion Engineered Carbons. You might have seen in the last year they've changed the name to Orion, which is easier. Celso spent 25 years in the chemical industry. He was involved a lot with Cefic, so he knows Brussels quite well. But he told me he quite likes Berlin as well. Welcome, Celso. Last but not least, we need technology to make the chemical recycling work, and it's a very, very special pleasure to welcome Chris. At first time I pronounced your name in a conference, Krzysztof Wroblewski. I know pronunciation might not be right. I take the liberty to call you Chris, and we are friends for years. You're a CEO of Contec SA, a new company in Poland, really rocking it at the moment, as I can see, with expanding capacity, investing into a recovered carbon black lab. You have been CTO and CO. Welcome, Chris. So, chemical recycling. What I suggest, we structure the panel in 3 parts. And the first part really is, what is chemical recycling? Because we've seen, in this event, we've seen different types of chemical recycling. So I want to spend a little bit more on defining what do we actually mean with chemical recycling. Is the chemical recycling enough for the circularity of tires? All these things. Then we want to go into details, into success stories, and the last one, I think we talked a lot about governance and the conditions to make the circular economy work. And I think my panel has a lot to say about this. First question, chemical recycling. Let's go round through the panel. Where do you see chemical recycling specific for tires? And maybe we can start with Chris.
Okay, thank you, Martin, for a kind introduction. So, chemical recycling. Even though I'm representing Pyrolysis company, I think that chemical recycling should be the last thing to do with the tires, because everything that can be mechanically recycled should be mechanically recycled. But still, there's some questions about the market potential for all the mechanical recycled goods that arise on the market. That's why chemical recycling comes in, because we can create a bigger loop in the system and create some raw materials that are equal or sometimes surpassing with quality of the raw materials. So chemical recycling as something that's really had to change this chemical structure of the waste that we process. I think it has its place. It should not be the first in line, because we will not build the capacity which is required until 2050 or 2030. But I think it's there, and it's really solving some of the issues that all the guys here have.
All right. So for me, it's also about how you define, right, the chemical recycling. If you are just shredding the tire and making parts, or trying to bring it back to life, but in a tire, it is very difficult just to cut it and bring it back in a product that has, I'll say, a lot of performance and safety issues, right? So, and this is why we work together in the Blackcycle project to make tires with the same quality again. And there, with the pyrolysis process, of course, you bring, you can extract this oil and then make the carbon blacks that we make, as Margarita mentioned, to the same quality. So you can make tires again, and which is not only about the performance of the tire, but also the safety, which is one of the performance criteria of the tire. So it all depends on how you define, right, the chemical recycling in this context.
First of all, thank you to EuRIC for inviting us to share our views on this. So at ZeroWasteEurope, we're also working a lot on chemical recycling, and here again, recalling that we are not against chemical recycling per se, but we also think that it has a role to play and comes as the last results, that solution after prevention, reuse, and mechanical recycling happens. So from that perspective, we think that it has a role to play. And there, again, when it comes to also recycling more in general, if we, in our opinion, if we think we really have to be serious about recycling, we also really need to think at the production level. So what we put first on the market has to be designed to be recycled, And from that perspective, we really think that there recycling will have a role to play and not just being kind of an excuse to keep business as usual, because we have this circularity discussion that is really important, but more from a broader aspect, the environmental impact of these different recycling technology has to be considered, and also how they are delivering in terms of different decontamination, but also air pollution. So that's why from our perspective we need a ranking, and from this perspective mechanical recycling should happen first because of its environmental impact, and there afterwards regarding the different layers of chemical recycling and if it's or not chemical recycling, then we have a discussion. But what is also really important from our point of view is to really say that all rules applies to all the players and that the same conditions are also met. Also saying that all pre-treatment are necessary for all recycling is also something that needs to be acknowledged, and this is not what we would see sometimes in the discussion. So having an open discussion when where is chemical recycling has its place and under which condition.
Okay, I totally agree with you about where we have to make the chemical recycling, because as I tried to explain, it's the ultimate way to recycle tire because it's a composite. Michelin have a circular economy philosophy with the 4R. The first one is reduce the mass, reduce the quantity, reduce the consumption. That is the first one. The second one is reuse, retreat. That is a good way. After that is renew. Yes, we was talking about biogenic, bio-based raw material. Bring to the tire. At the end, recycle. So mechanical recycle, and then chemical recycle, because it's the last one is a molecular treatment to recover high value raw material. And there are little difference between chemical recycling of plastic and rubber that we recover the recovered carbon black. It's directly used could be directly used in different applications. Yes, and then we have oil that it could be used for segregated value or for mass balance approach.
So we have stated, you all stated, chemical recycling might not be the be-all, end-all of tire recycling and sustainability. You mentioned mechanical recycling. Margarita, you mentioned reuse. Maybe you include retrading in that, even in a working ecosystem. Now, one part of chemical recycling can be pyrolysis. Another part could be devulcanization. We don't have a devulcanization. We had Daniele presenting, so that covered the devulcanization. In terms of pyrolysis, I think there are quite a few misconceptions in a way. Is it recycling? Is it energy recovery? It's maybe a little bit a biased question. Chris, what would you answer to somebody asking you, is it energy recovery? Is it material recovery? Where does pyrolysis stand?
Basically, I would ask you, because if you have a tire that approaches or arrives at our plant and 85% or 83% of it is turned into sustainable raw materials, is that materials recycling? I think yes. Of course, we need some energy for the process, and this energy is usually being created in the process by creating the non-condensable gas. So we're burning something, yes, but still we're working on the technologies that will allow us to avoid that in the future. Nevertheless, if over 80% of the tire which arrives to the plant is being turned into materials, I think it's material recycling, yeah.
Celso, you want to say something?
Yeah, just complementing, right? So basically you are turning the material into new material again. So it is basically a fantastic way for the circular economy, right? So you need to find ways to make it more efficiently, right? So this is what we're investing so much money in R&D to make it more efficiently, to reduce the energy, because we all have vested interests in reducing the energy, because energy costs money, right? And it also causes emissions. And so that's why we need to look at it from a global perspective and have all the different technologies, and they'll be competing against each other, right? So the more efficient technologies will be the winners in the future, and that's what our economy is about. Right? So I think nobody has the interest here in, I would say, just creating something that will harm the environment, or that has more energy, right? So we all want the same thing, and all these technologies will be competing. And I think with the Blackcycle, we proved that something really works, and it's getting better.
Lauriane, from what you have experience in the plastic side, but as we learned today, of course, plastics are quite different from tires, because tires are vulcanized and cannot be melted again. What is your experience with the energy use, and what would be your message?
Yeah, I'm working mostly on plastic here, and so it's a different field, but the main point that we always say here, and also when it comes to pyrolysis and different types of outputs the process can have, first, when the pyrolysis oil is used to produce fuel, this part we should be sure that, and we're calling it here frankly, that this is not recycling at all. It's even defined like this in the Waste Framework Directive. So this part is really not considered as recycling. And afterwards, when it comes to the different yields, and what we see is that the yield is quite low in comparison to other technologies. And also what we see as well is that there is a high need of diluting the pyrolysis oil with virgin naphtha when it comes to the refinery. And so there, the question of having a recycling technology that is efficient is, from our perspective, a bit questionable, in the sense that if we need to have a high dilution factor to be afterwards be able to process pyrolysis oil in the refinery, those still count as a recycling. So that's why we will make a differentiation in our views that when it comes to pyrolysis, we usually define it as a chemical recovery, which would be completely different for energy recovery, and in between, in the sense of having a hierarchy where we also shows the different yields and the different differences between the different technologies.
Right. So my background was actually in plastics. I went many years in plastics recycling as well. So, but on the rubber, as Martin mentioned, so this is a vulcanized material. So we need. So first, when you recover part of the carbon black already, and then in the pyrolysis process, then you produce an oil, right? And so this oil can replace, I would say, virgin oils to make the same quality carbon black. So basically, it is a very different animal when you recover a mixture of products that were in the tire, that you cannot use that one-to-one to replace virgin products, and when you want to make something that is the same quality. So when we prove that it works with the pyrolysis process, and what you're mentioning about yield differences, is that the technology that was optimized for over 100 years of making carbon blacks is a commodity that is there for 100 years. Our oldest plant is over 150 years old. So that has been optimized for certain kinds of oils. And now with the tire pyrolysis oil, we are already improving, and we intend to get to the same level. So there will not be a kind of loss of anything. So just replace. Basically, this is the first part. You're concerned about the loss. So this will be overcome over the years. And the other point is, today you do not have enough tire pyrolysis oils because there are just a few plants. So they're small, they're just getting up to speed. So basically, over the years, our hope is that this will proliferate, right? And in the beginning, you need to start mixing it because you do not have enough. But in our project, we have proven that we can make with 100% pyrolysis oil, we can make the same quality of carbon black. And this was tested by Michelin in all the different parts of the tire. So this is just an interim solution that you need to mix to come to the, I would say, the holy grail in a few years from now, so that we'll be able to transform the industry into the, let's say, a wholly recyclable industry.
I may add on top of that, there's another intermediate solution. I mean the mass balance fuel exempt approach. And I think it's really beneficial because if there is a scale of, I don't know, 10,000 tons of oil per annum, nobody will build dedicated petrochem refinery for bringing, I don't know, sustainable styrene for the tire production. But if we have the mass balance fuel exempt approach, we could reduce using hydrocarbons which are from fossil source and allow us small companies to grow with creating bigger capacities. So there is a really sense in bringing the scale of these refineries or petchems to allow for different applications.
Margarita, where would you see chemical recycling? If I asked you the same question I asked Daniele, and knowing that the Blackcycle group has very ambitious goals to recycle every second tire, so 50% of 3.5 million. Where do you see the potential for chemical recycling? You look mainly at pyrolysis, but if you include devulcanization, where would you see chemical recycling to be?
In fact, yes, you are right. The ambition of Blackcycle and mission of Blackcycle is to recycle to propose technology to recycle at least 1 million tons of end-of-life tires. And today, we think it's possible to have the market of the secondary raw material to treat this quantity of end-of-life tire. But if we can have more tires, it could be better, because with that, for sustainable carbon black, to replace all the carbon black in general is in Europe, I don't know how it is. The global market in Europe is like 12 million tons in Europe of the market of carbon black. So we have enough market of secondary raw material to replace, to treat a lot of end-of-life tire. But as we said, the key question is the equilibrium, the balance between mechanical recycling and the chemical recycling. If we can find solution of devulcanization, micronized rubber powder, using selected granulate, having better and better quality of mechanical recycling or devulcanization one. First we go to this one, and then we will try to make chemical recycling. For our ambition, what it was the first objective is to avoid all the exportation of end-of-life tires to go through other countries of the Europe, yes, and especially in cement steel. Yes, that is a key point. Yes, because
that
today,
was the objective, right? To avoid the exports.
Yeah, avoid the export. Exactly. It's half of the end-of-life tire today export and goes to the cement steel. So it's to reduce energy recovery for the tire. So I think we have the place for chemical recycling, for material recovery for tire, and for other applications as well. That it was explained today, the other actor today.
Chris, you are one of the success stories of the recycling companies that scaled up. You, for some time, you didn't even have technology for recovered carbon black. You added that, you added an expansion, and you go. Can you share your story? What made it possible to grow? Also, you have collaborations that surely have helped you. Let us know your success story. What is your recipe?
I think that short answer is patient and really supportive investor, and I believe we are one of the only ones in the industry that have really good private equity investor that really is patient and understands the business and wants to go deeper with that. But it was verified with successful fundraising last year, and last year in Cleantech, I believe that it was impossible to raise money, but we did successful fundraising for 50 million euro that allowed us to expand the plant. I think that the answer is the consistency in what you do, and then really realizing the strategy you have taken. But the collaboration you said before helped us a lot, and those collaborations with stakeholders from different parts, also inbound, like from tire recyclers, mechanical tire recyclers, to understand the feedstock, and also like our cooperation with TRS that allowed us to work on, I think, one of the fundamental things in bringing circularity in tire manufacturing. That is in rubber application laboratory in recovered carbon black, the in rubber performance of recovered carbon black. Once you understand that, it's much easier, because with such a new product you need to teach your clients how to use it actually, and it's not that easy.
Thank you, Chris. Celso, would you like to talk for your pyrolysis partners and Margarita? What have been success factors for scaling up the availability of sustainable feedstocks? What is the success story over there?
Yes, I think the first part of the success story is very well understanding the application, right? So I think we've been supplying the tire and rubber goods industry for many years, so we understand what are the parameters, the technical parameters. So when we develop a product with a different feedstock, there is a lot of development that we need to do, and we know exactly what parameters we need to get, right? So I think at Orion, since we are the only, I'll say from the top global carbon black producers that has, I'll say, very small scale reactors for the specialties business, and we rubber could use it for this project. So we can, in a very small scale, develop the technology that is needed to process those different oils, because those oils are different from the oils that we usually use. So for us it was very important to have that kind of capability, understand the quality that we need to reach, and then do a lot of testing until we say, okay, this is exactly what we need. And then we needed to test at different levels, right? So, and then increasing, go to a larger scale. This is what we call the biggest pilot plant, and then come to something that we can reproduce at a commercial scale. So we proved that the product works with 100% pyrolysis oil, that it can completely replace the normal fossil fuel oils. So for us that was very important. So we work together with the pyrolysis partners, because they need also, of course, to understand what kind of parameters would be important for us to process it, right? Give them feedback, and come to, I'll say, an improvement of the yields for us. So first getting to the quality, and then it's kind of improving the concept. Now we know that we can replicate it, different plants. We already launched the products commercially, and for us it's about
this is EuRIC circular, right?
EuRIC circular,
300 type.
Yeah, we have actually produced everything. 200 series for the thread, right? And then you have 300, 600, 700. We have different grades. So for us, these were the most important things. So having the capabilities in hardware and having the application knowledge, and the rest is process technology that you keep improving to get it not only the right quality, but something that is economically feasible and that our customers at the end can use.
Thank you. Lauriane, there's not only success topics, but there's also concerns maybe of the public, of people who don't know what is pyrolysis. Sounds dangerous. Pyro is fire. Are we incinerating? Are we burning? What are the big concerns you think that the public has and concerns you have identified? And what can you recommend us to better inform the public, to mitigate, to actually avoid all those concerns? Because I think this is one, if not the key enabler for bringing circular economy and chemical recycling forward.
Perhaps to also turn back on some points that I've been saying, and so to answer your question, it's been mentioned the use of mass balance with a field use exempt model. A lot of discussion happening regarding the plastic on this issue, but one really important concerns we have, and it's been also raised by consumer organization actually, is that when we have this mass balance, no claims can be done in a really chemical and traceable way at the product level. So any claims done at the product level using a mass balance approach would lead to greenwashing simply. And we are not the only one saying it. It's been also said in another sector, the textile industry, but the Dutch Consumer Protection Authority has been suing Zara and H&M because they have been using recycled cotton claims at the product level, and there wasn't any concrete proof that what has been said on the product was really there. So for us, having these claims at the product level when we use a mass balance would lead to really big greenwashing, while at the same time the EU is really trying to fight against this under the green claims. So this is one really big point that we see there.
Transparency.
Yeah, transparency. Also, when it comes to pyrolysis, a lot has been said the recent years, and a lot of our time has been also on debunking a lot of claims that were made around pyrolysis. So I think there's also a big need of transparency on what goes in, what goes out. And one really important point there is that when we use pyrolysis with like eating the waste, more or less, we also have a lot of inside chemical reactions. And there one of our main concerns is also what's the fate of the chemical substances there. I mean, we also know that it does not disappear because of the heat. It's not strong enough. Not like incineration, where dioxins are not there. So what do we do with these substances? How do we address it? How do we have really something that is safe? So that's really an important point from our perspective. And last point, also raising me a lot of concerns, is when I see the mix of bio-based and recycled content. Well, this is completely different type of mechanism and product in itself, and we do not see the need to mix it, because in the end, when we were speaking at the beginning about recycled content, the idea was really to have more circularity. Well, why would I need to act on my design in the first place if I can have bio-based plastic replacing recycled content at some point? I mean, I'm not saying this is the case for tires, but this is what's happening on the other field of plastic, and we see it happening in different sectors. So it's all perhaps on our side are really concerns that we see everything being mixed when in the end this is not the same purpose. One is about sourcing, and one is about the end-of-life treatment we have.
So 3 things. So you have transparency, toxical substances, and the mix of renewable and circular content. Question to the panel. Celso wants to reply.
Oh, you want?
Yes, why not? Because it's a key point that you explained, that is Blackcycle projects want to answer this question, yes, because we know that on one hand the social acceptance of the solution is a key point, so it's very interesting to have this discussion, because at the end we want to have the guideline to our partners to deploy circular economy in general. So we are totally agree about the transparency, yes. And for the point of view and health and safety assessment, it's for that Blackcycle have a holistic project, because we work with EuRIC, is a key expert in this kind of study, that it was making a hazard study in the global value chain, and as well different measurements of the different composts to be sure that we manage the risk behind the pyrolysis, and to manage the soil and all the byproduct that we produce, and even the product at the end, because we make measures show sustainable carbon black, so the recovering carbon black, MRP. So I'm very happy, because that is the objective at the end of Blackcycle, to give all these answers to the social acceptance. Thank you very much.
But what the public sees, right? The public sees the image of the pyrolysis industry, maybe in India, in Pakistan, Bangladesh, where people just have a reactor and they open the reactor, and then we have emission, even solid particle emission, and then they think, okay, that is pyrolysis, and that is going to come to Europe, and it's really 2 different leagues of industry. Maybe Chris, you can tell. You don't have a pyrolysis reactor, you have a true chemical factory with everything before and after the pyrolysis, correct?
Yes, exactly. The technology itself is pretty unique, but if I may add on the previous topic something, I think those issues or questions are being addressed because every client right now really demands, not asks, demands ISCC certification, so third-party certification that really approaches the questions in terms of traceability. We need to really audit our entire supply chain to make sure there are post-consumer tires. And the second part, I think the guys from ZeroWasteEurope and Peter could tell a lot more about that in terms of health and safety. It's the REACH registration, and if something is REACH, it's product, and the TPO is REACH registered for years right now. Last year or the one previous, the certificate created this year for the recovered common black as well. So all those things are being addressed. So it's also because this industry is being serious. All the major stakeholders are in there. Michelin invested in Enviro, Continental invested in Imperial, Berlin is with Cirtec, and there's lots of money to be lost if something is done wrong. That's why I believe that this is a really strong incentive to do things right, because from the day one we have to supply tire manufacturers. This is our only option, and we need to comply with all the regulations that they insist on. And it's a struggle for a small company. We hire 80 people right now. It's a really struggle. But we're going to do that to supply those tire manufacturers because they like the quality and they like the sustainability and the carbon footprint of our products. But what was the question?
He was explaining that you not only have a pyrolysis reactor, but you have a true chemical factory that is dealing with all materials with the required safety, and you answered it. Exactly,
and the one thing which is very important, I think, is that the operational excellence is something completely different than the R&D in small scale. because you can create quite easily pyrolysis of, I don't know, 50 kilograms per hour or whatsoever, or in batch scale. But then when it comes to taking care of your operations in one of the, in the full industrial scale, it's completely different level, and you need a really good team for that. And actually, we're gonna put first rubber granule in our reactors, new reactors, in I think 2 weeks from now. We already melted the salt for the third and fourth line, and it will be one of the biggest plants in Europe right now. And I honestly think that one of the biggest challenges would be keeping the operations on the really high level, because it's a challenge for small companies to do things first time. Yeah? And I think that most of the industry really forgets about it, how to scale actually. Yeah.
Now, to spike things up a little bit, we talked about mass balance. Is it a good thing, a bad thing? Do we need to correct the ways we look at mass balance? You said ISCC is demanded by customers. It's of course a convenient system where we have possibility to attribute green credentials to a product where the raw material is not a big volume in a big volume available. Good or bad? Do we have to change it? Do we have to advance and progress it?
I'll be quick, because I told already that I think that mass balance is the right but intermediate approach. It should last as short as possible, but this is the enabler. I mean, with such a small scale that we're producing right now all together in the entire pyrolysis value chain, this is enabler to really scout for the best applications for the products.
Celso?
If I may compliment, so I see also as an interim approach, and that's why it was important in our project that we validate that with long term, with 100% TPO, we can produce the quality of the products that the customers need. So for us, you need first to validate that it works, and then we need to work progressively with the volumes of the product that is available, and then move towards that. That's why I think the mass balance is very important. And the ISCC certification, I think this is third-part verification, so that you, the plant, so for instance, he has the certificates for the tires, so he produces the tires, ships the material to us, and we cannot, we produce 1 million tons of carbon black per year, so he will produce a little bit of the oil. So in the first few years it will be very little, then over time it will increase. But the important thing is that in the auditing process, so that I think perhaps that the public better understand how it works, so that you exactly you need to certify whatever comes in and whatever comes out, and whatever comes out needs to be less than what comes in, because you have losses, right? So that comes to our certification, and then to our customers, to the tire customers, and then they need to use it further. But I think differently from other processes, in our process we inject the different products, so the oil and the recycled oil. So in fact, if we say it is 5% or 10% or 20%, the product can be measured. So you can, if the product that he supplies has kind of 40% biogenic content, we can do a C14 analysis of our product, and you find exactly that proportion. So that point about validating, in our cases, we use the product directly into our product. It doesn't disappear in a refinery or anything, right? It goes directly. So we buy the oil, we buy the TPO, they're injected, they go through the reactor, and we make carbon black. So it can be completely traced. So that's why I think there is a difference between that and refineries.
Lauriane, with what you learned today from the world of tires, how do you think now? We got some 4 minutes left, so I really want to hear your voice about that. And then we do a last question.
Yeah, sure. So how it seems to be described to me, then it's just that if you can segregate everything, then why are you using a mass balance if everything can be segregated? Because apparently you can measure at each step, so you know what comes in, what comes out, without mixing it everywhere. So it means that you can know the exact proportion, and you don't need, if it's not segregation, you can still use a controlled blending approach, and then mass balance would not be needed. So that's why for me now it's a bit not super clear, to be frank.
No, it's that the products are. It is very small today. So if I get just a little bit of TPO, I cannot have a complete separate infrastructure just to make those grades. That's impossible in an industrial production. So I need to feed the product together with the other product, because otherwise I'll need completely different infrastructure. That is impossible in a commercial operation.
So then you are like mixing it with everything, you're not just like
No.
So that's why for me it wasn't clear.
I'm not mixing. It goes directly into the reactor with the other feedstock, but I cannot have a separate line to make just TPO because it's very small today. So that's why you need the mass balance.
Then.
Yeah,
it's diluting. And that's why for us, recalling it again, but when we're using mass balance, no claims at the product level are like acceptable, because otherwise it would be greenwashing. So yeah.
No, the claim is about the percentage that is in.
Still, like you cannot prove in the end of the product that you have this recycled content.
Yeah, you can measure it.
Because you're allocating it to part of the production.
No, you're not allocating. You just you measure just for those products. Just for those products, you have the complete allocation. You have the dosing.
Then
you physically have TPO.
Yeah, you physically have TPO.
So then you don't need.
We got 1 minute left. Maybe Rob has one of his good questions, and then we finish the panel.
I just speak without thinking. So I just want to just counterbalancing that. I think, Lauriane, you are right to be concerned about dioxins and furans in these processes. You are right, because they are formed and there is a need to remediate that. But I would caution against confusing plastics recycling with rubber recycling. I've been doing this for over 15 years now, and I can tell you plastics recycling is at least a decade behind the technology of the most advanced rubber recycling operators. In Europe, plastics recycling and rubber recycling are regulated differently. Rubber recycling and pyrolysis is regulated as a waste incineration process, which means that it has to have its emissions heated to 850 Celsius for exactly the dioxins reason. The regulation exists today to ensure that the emissions from these plants have been thermally oxidized. So I think your concern is right, but I think the answers are there. And then my final thought to you is, what is the great lesson of policy and economics of the 20th century? There's one lesson. It's that centrally planned economies do not work. There's a reason that communist economies failed and market-based economies triumphed in the 20th century. When you go and start talking about chemical recycling versus mechanical recycling, there's a real danger of descending into an argument about where the deck chairs are on the deck of the Titanic. Because the numbers are that about 1.5 million tons a year of rubber is incinerated or exported predominantly to the developing world today. And in the 15 years I've been doing this, that has not improved very much. So we can all argue about whether ideologically chemical recycling is more or less pure than mechanical recycling. But 1.5 million tons a year and growing is being burned and dumped into the developing world. So right now, how about we just make any kind of progress?
I think we couldn't finish on a better note. Thank you to the panel. Thank you, Chris, Celso, Lauriane, Margarita. Thank you very much.